Double integrals in volume. Let's suppose we have this region. You can call this region R if you want. It can be a rectangle, can be otherwise. And over top of that, we have a surface, z equals f of xy. We already know how to integrate over a rectangular region, but if we decide to integrate over the rectangular region this function, then guess what? We have this tall parallel pipe bed. This dimension is dx, this dimension is dy. Actually, I got that switched. That's dy, that's dx. And the height is f of xy. And so if we multiply all three of these dimensions, we get a small element of volume dv. And the volume will be the double integral over this region R, f of xy, dy dx. So this double integral can represent a whole lot of things. Last lesson we saw it could represent mass. We can use that to calculate average value, and now we can add it up to be volume. So here's a simple example. These can get quite complex, but not until we have more kung fu in our math repertoire. So we stay pretty simple. We have a function f of xy equals x squared plus y squared. We want to find the volume under this over this Cartesian product or this rectangle. This is an elliptic paraboloid. Picture is really quite simple. Looks like this. Well, we have this rectangular region in the xy plane, and so there's going to be a volume underneath this. I won't bother drawing it, but you can conceive of the volume underneath that, bowl-shaped and bounded. The sides are going to be planes and the like, and the base is going to be this rectangle. Well, quite simply put, the volume is equal to double integral 0 to 2 x squared plus y squared dy dx. And now we just have to figure out how to do the antiderivative. Well, we integrate inside first. X squared dy, x squared is constant, so we have x squared y. Y squared dy gives us y cubed over 3 from 0 to 2 dx. Plug in 2, plug in 0. Plug in 2, you get 2x squared plus 8 thirds. Integral 0 to 2, 2x squared plus 8 thirds dx. And now it's just a Calc 1 integral. Okay, and if we plug in 2, we end up getting 16 thirds plus 16 thirds, which ends up being 32 thirds, or 10 2/3. Okay, not much more to volume in this section. So we'll be back with another mass problem shortly.